Hello everyone, I'm Xuan from the Neurospin Computer Laboratory at the University of Texas at Dallas, and today I will give a brief overview of the reversible Skyrmion logic system. First, I will briefly summarize the concept of conservative logic. As the gate shown on the left, similar to billiard balls, the presence of a billiard ball is a 1 and the absence of a ball is 0. Here we have input ports P and Q that each have a binary value. The ports on the right outputs the corresponding value of this logic gate. If only a single P or Q is equal to 1, the corresponding information carrier, in this case an imaginary billiard ball, will just go straight toward its output ports on the right side. If both P and Q are equal to 1, these balls will collide, and this elastic collision are critical to this reversible computing system. Assuming perfectly elastic collisions and a friction-free surface, no energy will be dissipated by this reversible computing system, while this system conserves all energy but by not destroying any information. In this case, the number of the output billiard balls is always equal to the input balls. The signal gate on the right shows another example of the conservative logic gate. What can be used as these billiard balls? Here we consider skyrmions as a perfect candidate. Magnetic skyrmions are two-dimensional quasi-particles that can exist at the interface between a ferromagnet and heavy metal, as the structure diagram shown here. As you can see in this diagram, we apply the current in the plus y direction here, which through some complex physics causes a spin Hall force to push the skyrmion move into the same plus y direction. There's also a Magnus force called skyrmion Hall effect that causes the skyrmion to move toward the minus x direction here. To control the motion of the skyrmions, we can use the track structure with walls that repel the skyrmion and force it to stay inside the track. Finally, we will use the skyrmion repulsion between two skyrmions. This structure is then used to implement reversible logic gate. Shown here is an AND/OR gate. This AND/OR gate is constructed with two straight skyrmion tracks and a junction in between. Skyrmion entering the A and B terminals on the bottom will be pushed by the spin Hall effect toward the OR and AND terminals on the top here, and they will interact with each other at the junction in the middle, where the skyrmion tracks are opened. Again, the presence or absence of the skyrmion represents 1 or 0 respectively, and the number of input skyrmion numbers is always equal to the skyrmions at the output. This video illustrates the AND/OR gate with all input combinations beside the 0-0 case. When only a single skyrmion appears at the input ports, it will just propagate to the top right output port directly. But when both inputs are equal to 1, then the two skyrmions we can see are repel each other at the center bridge and force that bottom skyrmion to the AND output port here. Apart from the AND/OR gate, and a complete computing system requires fan-out and inversion functions. Here we show a skyrmion inverter copy gate where it implements two functions. First, it duplicates the input signal here, and second, it generates the inversion of the input signal, well, here. And on the top, there we show a truth table of this, and again, the output skyrmion number will always equal to the input skyrmion number. This is a video for the inverter copy gate. While the control signal on the bottom is constantly 1, the central output port on the right is always opposite to, well, we'll see the input in. So not is always opposite to input in, while the top and bottom output ports are always equal to the input in here. To synchronize these magnetic skyrmions, we have proposed this notch-shaped skyrmion synchronizer, as you can see in the diagram on the left. This notch here, it prevents the skyrmion from passing, as the skyrmion will get stuck at the notch. However, if the current density that we used to drive the skyrmion is increased, the skyrmion actually gets smaller, as we can see the radius versus the current density figure on the right here. Therefore, the current density pulse on the right will allow the skyrmion to pass through this notch, meaning that we can use this current pulse to actually synchronize in the skyrmion motions within stages. This video shows the skyrmion controlled by the current pulse shown on the bottom right corner. The skyrmion is first blocked by the notch, then passes with the increased current magnitude. So using that synchronization process, we can perform cascaded logic operations and have large complex circuits. So here is a 1-bit flatter, as you have seen most of them the building blocks in the previous slides. So first we have several inverter copy gates, and we have a set of well, here we have 3 wire OR gates. So this constructed with 2 half adders as marked in the purple boxes. On top of that, we have 2 layers of synchronizers corresponding to the current density map on the top. And then we can have this like 1-bit flatter to be implemented. The entire system is driven by the same clocking signal. There is a constant low current, as we can see. Generally, there's a global low current that causes the skyrmion to move, and like to move to the notch, I would say. And we periodically increase the magnitude of those driving currents to actually shrink the skyrmion and let them pass the notches. This micromagnetic simulation video shows this cascade 1-bit flatter with all the skyrmion motions and interactions within the gates. The latency of this flatter is 2 clock cycles for carryout and 3 clock cycles for the sum, with a throughput of 1 full addition per clock cycle. So we can see at next clock cycle they all move to the next stage. So here comes to the conclusions. Skyrmion logic provides potential for high-speed, low-power, non-volatile computing, and the proposed reversible Skyrmion logic system is highly scalable because of the direct cascading mechanism, the simple global clocking scheme, and its high robustness. The conservative logic paradigm enables a dramatically decreased power consumption by precluding the need to create or destroy skyrmions. And here are all contributors to this work. Thank you, and I'll see you in the QA session.